Hello dear students, hoping that all of you are good and fine. Okay, so we continue our discussion of the same subject, statistics, and in that we were discussing the particular module, Unit 5, analysis of univariate data. Okay, so as this is our second week, I take this as lecture 2. Okay, so as this is our second class, so same module, that is unit 5, fifth unit. Okay, analysis of univariate data. So before I take up the further aspects of this module, let me take 1 or 2 minutes so that we can conclude the things what we discussed in our previous class. Okay. So in our previous session, we discussed about the meaning of univariate data, something where we focus on the data of single in nature. Okay, then we came to know about the meaning of the term analysis, meaning of the term univariate, meaning of the term data. So at the same time we focused on the main subject, our subject, that is statistics, where we understood that statistics is nothing but numerical data, numerical facts. Okay, so when we collect all these data, after collecting all these data, okay, we need to give the conclusion about the collected data. So how to give the conclusion? It depends upon the statistical techniques, statistical tools what we are applying. So depending upon that, we can think of conclusion. So at the same time, we focused on the different measures of all these univariate data, because when I say that analysis of univariate data, the univariate data what we are collecting, that is to be analyzed. So when we are thinking of analyzing the data, we need to use certain measures. Okay, so or I can say that statistical tools. And in that case, we discussed about measures of central tendency. Okay, measures of central tendency, measures of skewness, measures of kurtosis. Okay, there are different measures. Altogether, we call this as statistical techniques. Okay, so we are collecting numerical data and we pool together all those collected data. Finally, we think of giving the results, and that outcome should be somewhat acceptable in nature. Okay, so all those things we concluded in our previous classes. So today we discuss about the particular concept where we take something average. Okay, because we know what are the essentials of a good average, essentials of a good average, and everywhere we focus on that after collecting the data which are in large number or sometimes in small number, we need a common thing, common factor, common central value, so that we can compare that common center value with other elements of the mass data. Okay, so we took the example of marks of the students. So 100 students are there. I am getting the marks of 100 students, and I am calculating the particular central value, and which can be compared with the rest of the marks. Okay, so ಎಲ್ಲ ಕಡೆ ನಾವು ನೋಡಿದ್ದೇವೆ ಡೇಟಾ ಇರುತ್ತೆ. ಸೊ ಆ ಡೇಟಾನ ನಾವು ಉಪಯೋಗಿಸ್ಕೊಂಡು ಅದನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಅದಕ್ಕೆ ಯಾವ ಸ್ಟ್ಯಾಟಿಸ್ಟಿಕಲ್ ಟೂಲ್ ಹಾಕಬೇಕು ಆ ಟೂಲನ್ನು ಅಪ್ಲೈ ಮಾಡಿ ಒಂದು ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ ನಮಗೆ. ಸೊ ಆ ವ್ಯಾಲ್ಯೂನ ಏನು ಮಾಡ್ತೀವಿ, ಉಳಿದೆಲ್ಲ ವ್ಯಾಲ್ಯೂ ಜೊತೆ ಉಳಿದೆಲ್ಲ ಡೇಟಾ ಜೊತೆ ಕಂಪೇರ್ ಮಾಡ್ತೀವಿ. ಸೊ ಹಾಗೆ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ವಿ ಕ್ಯಾನ್ ಜಸ್ಟಿಫೈ ಅವರ್ಸ್ ದಿ outcome what we are getting, that can be justified. So here we take some measures of central tendency that we took yesterday, where we think of central value and we have this average. So what is this average? So average is nothing but, okay, as we know, it is a single value. It is a single value that represents okay, the entire mass data. So it is a single value that represents the mass data, the entire mass data, because average is the common statistical tool applied by all the users of statistical data. So what is the reason for this? The reason for this is it is simple in nature. You can easily understand this average and you can easily convince this average and you can easily calculate the outcome by using this statistical measure. Okay, so that's what in the beginning they have taken this average while measuring the univariate data, and all these are nothing but measures of central tendency. So central tendency means this is what central value. It is a single value that represents the entire mass data. So the single value what you are getting, of course yesterday I took the example of scores scored by 5 students A, B, C, D, E. So 50 marks of A, 50 marks of B, 50 marks of C, 50 marks of D, 50 marks of E. Correct? So ನಿನ್ನೆ ನಾವು ಎಕ್ಸಾಂಪಲ್ ನೋಡಿದ್ವಿ, 5 ಜನ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇರ್ತಾರೆ, 5 ಸ್ಟೂಡೆಂಟ್ಸ್ ಮಾರ್ಕ್ಸ್ ಇರುತ್ತೆ 50 ಈಚ್ ಆಗಿ. ಸೊ ನಾವೇನು ಮಾಡಿದ್ದೇವೆ, ಒಂದು ಎವರೇಜ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದೇವೆ. ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದೇವೆ? 50 plus 50 plus 50 plus 50 plus 50 divided by number of students, 5 students, and we got the average of 50 marks. So that's what this is where you can find simple to calculate and easy to understand. That's what it is followed by maximum number of users of statistical data. So that is what the average. It is a single value that represents the entire mass data. So we got 50% average. That 50 can be compared with the rest of the mass data. Okay, so A is scoring 50, B is scoring 50, C is scoring 50, D is scoring 50, E is scoring 50. Okay, and we got the average as 50%. That average is nothing but single value, and that can be compared with other students' value marks. So that is what the 50 answer what you are getting, that is nothing but average. Okay, so further we focus on this concept average. So this is what our first heading, types of average. Types of average. Okay, so there are different types of average, but everywhere or in every time we get the single value, and that represents the entire mass data. So what are the types of averages? Number 1, arithmetic mean. Arithmetic mean. Okay, so number 2, median. Number 3, mode. Okay, number 5, geometric mean. Okay, so number 4, geometric mean. Lastly, number 5, harmonic mean. So everywhere you are finding the single value that represents the entire mass data. Okay, whether you think of arithmetic mean, whether you think of median, whether you think of mode, whether you think of geometric mean, whether you think of harmonic mean. Okay, but out of these five, first three, 1, 2, 3, these three are, they have given arithmetic mean, geometric mean and harmonic mean. Okay, arithmetic mean, geometric mean and harmonic mean are mathematical averages. Arithmetic mean, I take it as star 1 so that you can easily understand. Star 1, arithmetic mean, geometric mean and harmonic mean. These three are mathematical, okay, mathematical averages. And these two, I take it as star 4, star 5. These two are positional averages. Positional averages. Okay? Because you are finding a common term in these three things: arithmetic mean, geometric mean, harmonic mean. Okay? All these are mathematical averages. Mathematical means you are finding mathematical calculations. Mathematical calculations under these arithmetic mean, geometric mean and harmonic mean. That's what they are called as mathematical averages. Because we know we have taken x bar is equal to 15 plus 15 plus 15 plus 15 plus 15 divided by 5. So we got finally 15. So this is average. Okay. So what is average? It is a single value. We are getting a single value. It is a single value that represents the entire mass. This represents the entire mass. All this data can be compared with this arithmetic mean or average of 50. So that's what they have given in the form of meaning. It is a single value that represents the entire mass. But under the types of averages, again, all these are the types of average only, 5 types of average, starting from arithmetic mean to harmonic mean. But these three, arithmetic mean, geometric mean and harmonic mean, they are called as mathematical averages because we find mathematical calculations, whether it is addition, subtraction, division or multiplication. Okay, so we find all these calculations under these three categories: arithmetic mean, geometric mean and harmonic mean. For that purpose it is called as mathematical averages. You are finding here, this is the mathematical average. But in case of median and mode, where we find the position of the particular data, okay, and at the same time we represent this median and mode in the form of graphs. So and you know that when we prepare the graphs, okay, we find the value which is there in the particular position. Okay, that's what they have given. Median and mode, they are positional averages. It shows the particular position of the data, where it lies, where the calculated data or calculated numerical data lies. Okay, so where again we find median and mode for the data, okay, whether it is discrete data or continuous data, group data or ungrouped data, but it shows the position of the value. So I tell you in detail when we work out problems on these median and mode. So there I specify what is this positional averages. Okay, so when we work out some problems on these, definitely you will come to know why it is called as mathematical averages, these three, and why these two are called as positional averages. Okay, so for time being, just remember we are discussing measures of central tendency, where we think of central value which represents the entire mass data, and in that we have taken one of the central tendency, measures of central tendency, average. And in that average, we have 5 different types: arithmetic mean, median, mode, geometric mean, and harmonic mean. Okay, so ಇದೆಲ್ಲವೂ ಕೂಡ ಒಂದು ಸ್ಟ್ಯಾಟಿಸ್ಟಿಕಲ್ ಟೂಲ್ಸ್. ಯಾಕೆ ಈ ಸ್ಟ್ಯಾಟಿಸ್ಟಿಕಲ್ ಟೂಲ್ಸ್ ನಮ್ಗೆ ಬೇಕಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಅದರಲ್ಲಿ ಅವರು ಕಾಮನ್ ಆಗಿ ಫಸ್ಟ್ ಆ್ಯಂಡ್ ಫಾರ್ಮೋಸ್ಟ್ ಎವರೇಜ್ ಅಂತ ತಗೊಂಡಿದ್ದಾರೆ. ಯಾಕೆ ಎವರೇಜ್ ಅಂತ ತಗೊಂಡಿದ್ದಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಈ ಎವರೇಜ್ ಅನ್ನೋದು ಒಂದು ಸಿಂಪಲ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್. ಸಿಂಪಲ್ ಆಗಿ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು ಡೇಟಾನ ಇಟ್ಕೊಂಡು. ಆಮೇಲೆ ಇನ್ನೊಂದು ಅಂತ ಹೇಳಿದ್ರೆ ಈಸಿಯಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೋದು ಎವರೇಜ್ ಅಂದರೆ ಏನು ಅಂತ. ಓಕೆ, ಯಾವುದೇ ಡೇಟಾ ಕೊಟ್ಟಾಗ ನೀವು ಎವರೇಜ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಇಟ್ ಇಸ್ ಸಿಂಪಲ್. ನಿಮ್ಮೊಂದು 5 ಡೇಟಾ ಕೊಟ್ಟಿದ್ದಾರೆ, 10 ಡೇಟಾ ಕೊಟ್ಟಿದ್ದಾರೆ, 20 ಡೇಟಾ ಕೊಟ್ಟಿದ್ದಾರೆ, ಎವರೇಜ್ ತೆಗೀರಿ ಅಂತ ಹೇಳಿದ್ರೆ ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್. ದಟ್ಸ್ ವಾಟ್ ದೇ ಹ್ಯಾವ್ ಟೇಕನ್ ಇನ್ ದಿ ಬಿಗಿನಿಂಗ್ ಆಸ್ ಎವರೇಜ್. ಸೊ ಅದರಲ್ಲಿ 5 ಟೈಪ್ ಇದೆ: ಅರಿಥಮೆಟಿಕ್ ಮೀನ್ ಇದೆ, ಮೀಡಿಯನ್ ಇದೆ, ಮೋಡ್ ಇದೆ, ಜಿಯೋಮೆಟ್ರಿಕ್ ಮೀನ್ ಇದೆ, ಹಾರ್ಮೋನಿಕ್ ಮೀನ್ ಇದೆ. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಅರಿಥಮೆಟಿಕ್ ಮೀನು, ಜಿಯೋಮೆಟ್ರಿಕ್ ಮೀನು ಮತ್ತು ಹಾರ್ಮೋನಿಕ್ ಮೀನನ್ನು ಮ್ಯಾಥಮೆಟಿಕಲ್ ಎವರೇಜಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಅದರಲ್ಲಿ ನಾವು ಮ್ಯಾಥಮೆಟಿಕ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತೇವೆ. ಸೊ ಇಲ್ಲೊಂದು ಎಕ್ಸಾಂಪಲ್ ಮಾಡಿದ್ದೇನೆ. ಇವು ಏನು ಅಂತ ಹೇಳಿದ್ರೆ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್. ಈ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಇಲ್ಲದೆ ಇದ್ದರೆ ಈ ಆನ್ಸರ್ ಬರೋದಿಲ್ಲ. ಅದಕ್ಕೆ ಇವು 3 ಮ್ಯಾಥಮೆಟಿಕಲ್ ಎವರೇಜಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಬಟ್ ಮೀಡಿಯನ್ ಮತ್ತು ಮೋಡನ್ನು ಅವರು ಪೊಸಿಷನಲ್ ಎವರೇಜ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಅಂದರೆ ಆಫ್ಟರ್ ಅಪ್ಲೈಯಿಂಗ್ ದ ಟೂಲ್ ಆಫ್ ಮೀಡಿಯನ್ ಆ್ಯಂಡ್ ಮೋಡ್, ಮೀಡಿಯನ್ ಮತ್ತು ಮೋಡ್ ಟೂಲನ್ನು ಟೆಕ್ನಿಕನ್ನು ಅಪ್ಲೈ ಮಾಡಿದ್ಮೇಲೆ ಏನು ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೋ ಆ ವ್ಯಾಲ್ಯೂ ನಮ್ಮ ಕಲೆಕ್ಟೆಡ್ ಡೇಟಾದು ಒಂದು ಪೊಸಿಷನನ್ನು ತೋರಿಸುತ್ತೆ. ಸೊ ಹೇಗೆ ಆ ಪೊಸಿಷನನ್ನು ತೋರಿಸುತ್ತೆ ಅನ್ನೋದು ಪ್ರಾಕ್ಟಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ ಡಿಸ್ಕಸ್ ಮಾಡುವಾಗ ಮತ್ತೆ ನಾನು 2 ಕಾನ್ಸೆಪ್ಟ್ ತಗೊಳ್ತೇನೆ: ಮ್ಯಾಥಮೆಟಿಕಲ್ ಎವರೇಜ್ ಮತ್ತು ಪೊಸಿಷನಲ್ ಎವರೇಜ್. So when I take practical problems, definitely you can understand what is this mathematical averages, what is this positional averages. Okay, so what we do here is, under all these types, we are going to work out the problems, practical problems. ಈ ಎಲ್ಲ ಟೈಪಲ್ಲೂ ನಾವು ಪ್ರಾಬ್ಲಮ್ಸನ್ನು ಸಾಲ್ವ್ ಮಾಡೋದಿದೆ. ಸೊ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಟೇಕಿಂಗ್ ಆಲ್ ದಿ 5 at one particular time, we just split. ಓಕೆ, ಸೊ ಒಮ್ಮೆಲೆ 5 ಡಿಸ್ಕಸ್ ಮಾಡಿ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡೋದಕ್ಕಿಂತ 1 by 1 ತಗೊಂಡು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಫಸ್ಟ್ ಅರಿಥಮೆಟಿಕ್ ಮೀನ್ ತಗೊಂಡು ಅದರ ಮೀನಿಂಗನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡಿ, ಅದ್ರ ಮೇಲೆ ಏನು ಫಾರ್ಮುಲಾ ಇದೆ, ಸ್ಟ್ಯಾಟಿಸ್ಟಿಕಲ್ ಫಾರ್ಮುಲಾ, ಅದನ್ನು ಅಪ್ಲೈ ಮಾಡಿ ಪ್ರಾಬ್ಲಮ್ಸನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಆಮೇಲೆ ಮೀಡಿಯನ್ ತಗೊಂಡು ಅದ್ರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಆಮೇಲೆ ಮೋಡನ್ನು ತಗೊಂಡು ಅದ್ರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. Likewise, finally we take geometric mean and harmonic mean, so that you can easily understand all the 5 types of averages. Okay, so today we start with the first type of average, arithmetic mean. Okay, so that I take today, arithmetic mean. But try to remember the main heading, that is types of average. So that is what our concept of discussion, types of average. Okay, so in that number 1, arithmetic mean. So that I take first arithmetic mean, then we go for rest of the types. Okay, so ಇವತ್ತು ನಾವು ಫಸ್ಟ್ arithmetic mean ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಸೊ ಅದರ ಮೇಲೆ ಏನು ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದೆ we work out. ಓಕೆ, ಆಮೇಲೆ ನಾವು ಉಳಿದ ಯಾವ ಟೈಪ್ಸ್ ಇದೆ ಅದನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಓಕೆ, ಸೊ I write here number 1, first type of average, that is arithmetic mean. Okay, arithmetic mean. So what is this arithmetic mean? Okay, so I write here again, arithmetic mean, it is nothing but I take who has given the most popular and widely used measure that representing data. Okay, it is mostly used the mostly used statistical tool by all the users of statistical data. Okay, and we know that arithmetic mean, again where we are getting the central value which is representing the mass of data. Okay, under arithmetic mean, again we have 2 different types. So I take it as number 1 and number 2. Okay, so number 1 is simple arithmetic mean. Number 2 is weighted, okay, weighted arithmetic mean. So simple arithmetic mean and weighted arithmetic mean. So try to remember, we are discussing types of averages. There are 5 types of averages: arithmetic mean, median, mode, geometric mean, harmonic mean. All these are types of averages. So as I said earlier, we take one by one the types individually and we work out problems on that. Then we go for further types of averages. Okay. So I am taking the first type of average, that is arithmetic mean. Again here we are calculating a single value that is representing the mass of data. Okay. But they are classified for calculation purpose and depending upon the nature of data, we know that data are of different categories: group data, ungrouped data, okay, discrete data, then continuous data. So when nature of data change, we think of applying a particular formula. For time being, just I differentiate these two: simple arithmetic mean and weighted arithmetic mean. Okay, simple arithmetic mean. So simple average we are calculating. How it is calculated? Simple arithmetic mean is somewhat where we focus on all the individual observations, all the individual data. Okay, so as I told you, in this particular class, first PC commerce class, if I take, there are 100 students. If I observe, if I take individual data, if I focus on individual data, individual observation, that is nothing but simple arithmetic mean. So while calculating mean, we consider all single observations, all single data. Later I give you the meaning and definition, but for a time being just I am differentiating simple arithmetic mean and weighted arithmetic mean. Okay, so this is the arithmetic mean where we calculate mean, average, okay, by observing all the observations, all the data in detail. Individual data, individual observation we consider equal importance. We give equal importance for all the observations, all the single data. So that is nothing but simple arithmetic mean. But under this weighted arithmetic mean, as we know this weighted, meaning of weighted, where we give weightage to a particular observation, to a particular data. Okay, so weight I need to say, keeping in mind the observation, the data, giving weightage. Weightage number 1, weightage number 2, weightage number 3. It will be like this. I tell you the example. So same class, first PSC Commerce, there are 100 students. Now I want to calculate the mean of the marks scored by the students in the statistics. So ಇದೇ ಕ್ಲಾಸ್ ಅಲ್ಲಿ 100 ಸ್ಟೂಡೆಂಟ್ಸ್ ಇದ್ದಾರೆ. ನಾವು the average ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಸ್ಟ್ಯಾಟಿಸ್ಟಿಕ್ಸ್ ಅಲ್ಲಿ ಮಾರ್ಕ್ಸ್ ನಿಮ್ಗೇನು ಆಬ್ಟೈನ್ ಮಾಡಿದ್ರು, ನಿಮಗೇನು ಮಾರ್ಕ್ಸ್ ಬಂದಿದ್ರು, ಅದು ಒಂದು average ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು, ಮೀನ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಸೊ ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ಈಗ ಸಿಂಪಲ್ ಅರಿಥಮೆಟಿಕ್ ಮೀನ್ ಅನ್ನು ನಾನು ಏನು ಮಾಡ್ತೇನೆ, ಎಲ್ಲ ಮಾರ್ಕ್ಸ್ ತಗೋತೇನೆ. ರೋಲ್ ನಂಬರ್ 1 ನಿಂದ ರೋಲ್ ನಂಬರ್ 100. ಸೊ ಎಲ್ಲ ಮಾರ್ಕ್ಸ್ಗೂ ನಾನು ಏನು ಮಾಡ್ತೇನೆ, ಈಕ್ವಲ್ ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಡ್ತೇನೆ. ಎಲ್ಲ ಮಾರ್ಕ್ಸ್ಗೆ ಈಕ್ವಲ್ ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಟ್ಟು ಎವರೇಜ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೇನೆ. ಓಕೆ, ಸೊ 50 ಪ್ಲಸ್ 60 ಪ್ಲಸ್ 70 ಪ್ಲಸ್ 80 ಪ್ಲಸ್ 90 ಪ್ಲಸ್ divided by till 100th value divided by n number of students, 100. So where I am giving equal importance to all the observations, all the individual data. ಇದು ಇಲ್ಲಿ ಸಿಂಪಲ್ ಅರಿಥಮೆಟಿಕ್ ಮೀನ್ ಅಲ್ಲಿ. ಬಟ್ ವೇಟೆಡ್ ಅರಿಥಮೆಟಿಕ್ ಮೀನ್ ಅಲ್ಲಿ ನಾನು ಏನು ಮಾಡ್ತೇನೆ, 100 ಜನ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇದ್ದಾರೆ, 100 ಜನ ಸ್ಟೂಡೆಂಟ್ಸ್ ಮಾರ್ಕ್ಸ್ ಅನ್ನು ತಗೊಂಡು ಅದಕ್ಕೊಂದು ವೇಟ್ ಕೊಡ್ತಾ ಹೋಗ್ತೇನೆ. ಸೊ 99 ಆಗಿದೆ ಒಬ್ಬರದು ಅಥವಾ 100 ಆಗಿದೆ ಒಬ್ಬರು, 100 ಔಟ್ ಆಫ್ 100 ಅವರಿಗೆ ಒಂದು ವೇಟೇಜ್ ಕೊಡ್ತೇನೆ ನಂಬರ್ 1 ಅಂತ. ಓಕೆ, ಸೊ 95 ಒಬ್ಬರದಾಗಿದೆ ಮಾರ್ಕ್ಸ್, ಅವರಿಗೆ ವೇಟೇಜ್ ಕೊಡ್ತೇನೆ ನಂಬರ್ 2. 90 ಒಬ್ಬರದ್ದು ಮಾರ್ಕ್ಸ್ ಆಗಿದೆ, ವೇಟೇಜ್ ಕೊಡ್ತೇನೆ ನಂಬರ್ 3. ವೇ you are not giving equal importance to all the data. You are not giving equal importance to all the observations. Rather, we are giving weightage, we are giving weights as per the marks scored by the students. So more marks, more weightage, less marks, less weightage. Where I am not giving equal importance to all the data, all the observations. This is in the case of weighted arithmetic mean. So where we take weight as the base, weight as the base while calculating the mean. Here there is no question of weight. Here there is no question of weight. We take all the data, equal importance, apply the formula, get the value of mean. They, along with the marks, take the weight. Okay, marks into weight, you are getting divided by number of observations, you are going to get the weighted average mean or weighted arithmetic mean. Okay, so that's what the small difference between arithmetic mean and simple arithmetic mean and weighted arithmetic mean. Okay, so especially we take simple arithmetic mean today, then we take a weighted arithmetic mean. Okay, so here what is the simple arithmetic mean? I write here meaning simple arithmetic mean. So what is the simple arithmetic mean? Okay, arithmetic mean okay, which is calculated for a data, giving equal importance. That's what I said, giving equal importance to all the items in the okay data. That's what I said. We take all the observations, all the marks of the students, okay, and we give equal importance to all those data, all those marks. So that is simple arithmetic mean. At the same time, they have given one definition. This is what the meaning. They have given definition. Okay. So what is the definition? Arithmetic mean. Okay, is nothing but of a set of observations okay, is their sum divided by the total number of observations. So meaning as well as definition of this simple arithmetic mean. So meaning, they say that which is calculated for a data giving equal importance to all the items in the data. So same example, every time I take the same example so that you can easily understand. So 100 students, marks scored by 100 students, I collect all those marks and I am giving equal importance. So that is arithmetic mean. Okay, so ಎಲ್ಲ ಮಾರ್ಕ್ಸ್ ಅನ್ನು ಕಲೆಕ್ಟ್ ಮಾಡ್ತೀನಿ, ಎಲ್ಲ ಮಾರ್ಕ್ಸ್ಗೂ ಈಕ್ವಲ್ ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಡ್ತೀನಿ. ರೋಲ್ ನಂಬರ್ 1 ಇಂದ ರೋಲ್ ನಂಬರ್ 100 ತನಕ ಮಾರ್ಕ್ಸ್ ಇದ್ದು ಎಲ್ಲರಿಗೂ ಈಕ್ವಲ್ ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಡೋದು, ಅದು ಅರಿಥಮೆಟಿಕ್ ಮೀನ್. ಬಟ್ ಡೆಫಿನೇಷನ್ ಅಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ ಅವರು, ಅರಿಥಮೆಟಿಕ್ ಮೀನ್ ಆಫ್ ಅ ಸೆಟ್ ಆಫ್ ಅಬ್ಸರ್ವೇಷನ್ಸ್. ಅರಿಥಮೆಟಿಕ್ ಮೀನ್ ಆಫ್ ಅ ಸೆಟ್ ಆಫ್ ಅಬ್ಸರ್ವೇಷನ್ಸ್. What is the set of observations here? 100 students marks. Marks of 100 students. That is the set of observations. Okay. Is there some? Is there some? The observations what you are finding, what you are getting, the sum of all those observations. Okay. Divided by the number of total observations. So what is sum of the observations? As I said, 50 marks, 60 marks, 70 marks. So roll number 1 50 marks, roll number 2 60 marks, roll number 3 70 marks, roll number 4 80 marks, till roll number 100 80 marks. So sum of all the observations 50 plus 60 plus 70 plus 80 plus and so on till 100th marks. 100 student number or roll number 100, his marks divided by total number of observations. Total number of observations 100. So this is what the definition where we are getting arithmetic mean. Okay. So ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ ಅವರು, arithmetic mean definition ಅಲ್ಲಿ ನಾವೇನು ಅಬ್ಸರ್ವೇಷನ್ ಮಾಡಿದ್ವಿ ಸೆಟ್ ಆಫ್ ಅಬ್ಸರ್ವೇಷನ್ಸ್. ಸೊ ಇಲ್ಲಿ ನಮ್ಮ ಸೆಟ್ ಆಫ್ ಅಬ್ಸರ್ವೇಷನ್ಸ್ ಯಾವುದು, ಇದೇ ಕ್ಲಾಸ್ ಅಲ್ಲಿ 100 ಜನ ಹುಡುಗರು ಇದ್ದಾರೆ, 100 ಜನರ ಮಾರ್ಕ್ಸ್ ಅನ್ನ ಕಲೆಕ್ಟ್ ಮಾಡೋದು. ಸ್ಟ್ಯಾಟಿಸ್ಟಿಕ್ಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಸ್ಕೋರ್ ಮಾಡಿದ್ದಾರೆ ಆ 100 ಜನರ ಮಾರ್ಕ್ಸ್ ನ ಆಡ್ ಮಾಡಿಕೊಂಡು ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಸ್ಟೂಡೆಂಟ್ಸ್ 100 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದಾಗ ಏನು ನಿಮಗೆ ಸೆಂಟ್ರಲ್ ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೋ, ಏನು ನಿಮಗೆ ಸಿಂಗಲ್ ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೋ, ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಅರಿಥಮೆಟಿಕ್ ಮೀನ್. Okay, so in the meaning they have given that which is calculated for data giving equal importance to all the items in the data. So ಎಲ್ಲ ಡೇಟಾಗಳಿಗೆ ಈಕ್ವಲ್ ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಟ್ಟು ಒಂದು ಸೆಂಟ್ರಲ್ ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು. ಡೆಫಿನೇಷನ್ ಅಲ್ಲಿ ಅವರು ಫಾರ್ಮುಲಾನೇ ಕೊಟ್ಟುಬಿಟ್ಟಿದ್ದಾರೆ. ಡೆಫಿನೇಷನ್ ಅಲ್ಲಿ ಫಾರ್ಮುಲಾನೇ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ. ಏನು ಫಾರ್ಮುಲಾ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅರಿಥಮೆಟಿಕ್ ಮೀನ್ ಅನ್ನು ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು, ಎಲ್ಲ ಅಬ್ಸರ್ವೇಷನ್ ಸಮ್ ತಗೊಳ್ಳೋದು, SUM not SOME. ಓಕೆ, ಸಮ್ ಇನ್ ಸಿಂಪಲ್ ವಿ ಸೇ ದಟ್ ಆಡಿಂಗ್, ಎಲ್ಲ ಅಬ್ಸರ್ವೇಷನ್ಸ್ ಅನ್ನು ಆಡ್ ಮಾಡಬೇಕು ಮತ್ತೆ ಅದನ್ನ ಟೋಟಲ್ ಅಬ್ಸರ್ವೇಷನ್ಸ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದಾಗ ನಮಗೆ ಅರಿಥಮೆಟಿಕ್ ಮೀನ್ ಸಿಗುತ್ತೆ ಅಂತ ಅವರು ಡೆಫಿನೇಷನ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದಾರೆ. ಓಕೆ, ಸೊ ಜಸ್ಟ್ ರಿಮೆಂಬರ್ we are discussing the types of averages. In that, first type is arithmetic mean. Under arithmetic mean we have two classifications. Number 1 simple arithmetic mean, number 2 weighted arithmetic mean. So in that we are taking the first one, simple arithmetic mean. Okay, so meaning as well as definition of simple arithmetic mean. Okay, so some other concepts we take here. So I just this meaning and definition, hoping that it is clear to you about this average. Okay, because everywhere we find the formula. To be more specific, I can say that statistics is nothing but number formula. So number of formula, but we must know, we must understand when to use the particular formula. When to use the particular formula. So depending upon the data. Statistics ಅಂತ ಹೇಳಿದ್ರೆ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ, ಯಾವ ಕಾನ್ಸೆಪ್ಟ್ ತಗೊಂಡ್ರು ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ. ಬಟ್ ಆ ಕಾನ್ಸೆಪ್ಟ್ ಬಗ್ಗೆ ನಮಗೆ ಥಿಯರಿ ಇನ್ಫಾರ್ಮೇಷನ್ ಗೊತ್ತಿರಬೇಕು, ಆಮೇಲೆ ಡೇಟಾ ಕೊಟ್ಟವಾಗ ಯಾವ ಫಾರ್ಮುಲಾ ಹಾಕಬೇಕಂತ ಗೊತ್ತಿರಬೇಕು. ಓಕೆ, ಸೊ ಹಿಯರ್ ಇಫ್ ಐ ಟೇಕ್ ದಿಸ್ simple arithmetic mean. Okay, here we calculate under simple arithmetic mean. I take it as case number 1. Okay, because it depends upon the nature of data. As I told you in the beginning, it depends upon the nature of data. So case 1, ungrouped data. Okay, ungrouped data. This is individual observation. Okay. Because two things we have: ungrouped data, grouped data. Ungrouped data, grouped data. Ungrouped data means where we are not going to find a group of data. We find a single or individual observation. Okay, so there is no question of group of data. It is just like single variable, then group of variables. Single variable where we don't think of groups, but group of variables, it is a mixture of individual variable. Okay, so here ungrouped data. So two methods we have. I take it as a direct method. Direct method. Try to understand this concept. Now simple arithmetic mean ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೇವೆ. ಸೊ arithmetic mean ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂತ ಹೇಳಿದ್ರೆ ಅವರು ಡೇಟಾ ಕೊಡಬೇಕು. ಸೊ ಕೊಟ್ಟಿರೋ ಡೇಟಾ ಅನ್ಗ್ರೂಪ್ಡ್ ಡೇಟಾನೋ ಅಥವಾ ಗ್ರೂಪ್ಡ್ ಡೇಟಾನೋ ಅಂತ ಫಸ್ಟ್ ನಾವು ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು. ಓಕೆ, ಸೊ ಅನ್ಗ್ರೂಪ್ಡ್ ಡೇಟಾ ಅಂತ ಕೊಟ್ಟರೆ ಅದರಲ್ಲಿ ಯಾವ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಬೇಕು? ಸೊ ಅದನ್ನು ಎರಡು ಡಿವೈಡ್ ಮಾಡ್ತಾರೆ. ಒಂದು ಡೈರೆಕ್ಟ್ ಮೆಥಡ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಡೈರೆಕ್ಟ್ ಮೆಥಡ್ ಅಲ್ಲಿ ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾರೆ ಅವರು? x bar is equal to summation x divided by n. Simple formula. X bar in the sense arithmetic mean is equal to summation x. Summation x means sum of the observations. SUM, sum of the observations divided by number of observations. We get the arithmetic mean. This is particularly for ungrouped data, that to direct method. Okay, so ungrouped data ಕೊಟ್ಟಾಗ direct method ಅಲ್ಲಿ ನಾವು ಏನು ಮಾಡ್ತೇವೆ? x bar is equal to summation x divided by n ಅಂತ ಹೇಳ್ತೇವೆ. ಇಲ್ಲಿ summation x ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವ ಯಾವ observations ನಾವು ಮಾಡಿರ್ತೀವೋ, ಡೇಟಾ ಕಲೆಕ್ಟ್ ಮಾಡಿರ್ತೀವೋ ಅವೆಲ್ಲವನ್ನು ಆಡ್ ಮಾಡ್ಕೋಬೇಕು, ಆಮೇಲೆ ನಂಬರ್ ಆಫ್ ಅಬ್ಸರ್ವೇಷನ್ಸ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡಬೇಕು. ಸೊ ಸೇಮ್ ಎಕ್ಸಾಂಪಲ್ ನಾವು ನೋಡಬಹುದು. ಮಾರ್ಕ್ಸ್ ಅನ್ನು ಕಲೆಕ್ಟ್ ಮಾಡಿದ್ದೇವೆ 5 ಸ್ಟೂಡೆಂಟ್ಸ್ A B C D E. A 50 marks plus 50 plus 50 plus 50. This summation x is nothing but summation x is equal to x1 plus x2 plus x3 plus x4 till xn. Okay, so ನಾವು ಎಲ್ಲ ಕಡೆ ಹಾಗೆ ಬರಿತಾ ಇರ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ. x1 plus x2 plus x3 ಅಂತ. ಅದಕ್ಕೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಏನು ಮಾಡ್ತಾರೆ? summation x ಅಂತ ಹೇಳ್ತಾರೆ. summation x ಅಂತ ಹೇಳಿದ್ರೆ sum of all the observations. ಎಲ್ಲ ನಾವೇನು ಅಬ್ಸರ್ವ್ ಮಾಡಿರ್ತೀವಿ ಮಾರ್ಕ್ಸ್ ಅನ್ನ ಅವೆಲ್ಲವನ್ನು ಪ್ಲಸ್ ಮಾಡಿ ಎಷ್ಟು ಸ್ಟೂಡೆಂಟ್ಸ್ ಇದ್ದಾರೋ ಅದರಿಂದ ಡಿವೈಡ್ ಮಾಡಿ ಅವಾಗ ನಮಗೆ ಏನು ಸಿಗುತ್ತೆ? ಎವರೇಜ್ ಸಿಗುತ್ತೆ, ಅರಿಥಮೆಟಿಕ್ ಮೀನ್ ಸಿಗುತ್ತೆ. ಇದು ಯಾವ ಮೆಥಡಲ್ಲಿ? ಡೈರೆಕ್ಟ್ ಮೆಥಡಲ್ಲಿ. ಯಾವ ಡೇಟಾಗೆ? ಅನ್ಗ್ರೂಪ್ಡ್ ಡೇಟಾ. ಇಲ್ಲಿಯೇ ಒಂದು ಡಿವಿಯೇಷನ್ ಮೆಥಡ್ ಅಂತ ಬರ್ತದೆ. ಓಕೆ, ಡಿವಿಯೇಷನ್ ಮೆಥಡ್. So how do they calculate x bar here? So deviation method, ungrouped data, okay, x bar is equal to, right here, x bar is equal to a plus summation u divided by a plus summation u divided by n. This I put in one bracket, okay, where a represents, a is nothing but assumed mean. Assumed mean. So when to use this particular method? See, when they give the data, ungrouped data, okay, we just find the convenience. Convenience I need to say. When they give the ungrouped data, So we have two methods. One is direct method, one is deviation method. So it is just like if I give the example, you can easily understand. Okay. So I am giving ungrouped data, that is 100, sorry, 10, 20, 30, 40, 50. So assume that this is what the marks 10, 20, 30, 40, 50. Okay. So they ask you to calculate the mean, and these data are ungrouped data. Okay. So you are directly applying this particular method, direct method. X bar is equal to summation x divided by n. So what is the answer? X bar is equal to 10 plus 20 plus 30 plus 40 plus 50 divided by 1, 2, 3, 4, 5. 5. You are going to get the answer. Under direct method, x bar is equal to 10 plus 20 plus 30 plus 40 plus 50 divided by 5. So you are going to get the mean average. But what about this deviation method, where we take this A, assumed mean ಅಂತ ನಾವು ತಗೊಳ್ತೇವೆ. ಒಂದು ವ್ಯಾಲ್ಯೂನ ಕೊಟ್ಟಿರೋ ಒಂದು ಡೇಟಾನ assumed mean ಅಂತ ನಾವೇ ತಗೊಳ್ತೇವೆ. ಇದು ಯಾವಾಗ ತಗೊಳ್ತೇವೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ if they give the sales, okay, 1 lakh, 2,50,000, okay, 3,50,000, 4,80,000, 5,90,000 sales. Okay, just to remember, you can also calculate the mean by applying this method for this data. Okay, ಇದೇ ಡೇಟಾಗೆ ನೀವು ಇದೇ ಮೆಥಡ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿ ಮೀನ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ಬಟ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ವಿಲ್ ಬಿ ಲೆಂದಿ and it is a time consuming process. So calculation ಮಾಡಲಿಕ್ಕಾಗುತ್ತೆ ನಮಗೆ, because we use the calculators, definitely we can calculate the answer by applying this method also. To avoid the confusion, to save the time, okay, they use deviation method. So in deviation method alli ಏನು ಮಾಡ್ತಾರೆ, they take A, assumed mean, either 1 lakh, 2 lakh 50, 3 lakh 50 or any value. This they take as A, assumed mean. Okay, and all the sales are compared with this assumed mean. All the sales are compared with this assumed mean. Okay, 1 lakh minus 2 lakh 50,000, 2 lakh 50,000 minus 2 lakh 50,000, 3 lakh 50,000 minus 2 lakh 50,000, 4 lakh 80,000 minus 2 lakh 50,000, 5 lakh 90,000 minus 2 lakh 50,000. But the question is, how to take this assumed mean? It is our selection. That is one of the limitations of this method. But anyhow, this is our selection. Either you can take 1 lakh as assumed mean, 2 lakh 50,000 as assumed mean, 3 lakh 50,000, 4 lakh 80,000, or even 5 lakh 90,000. But one common assumed mean we take, and we find the deviation. We find the gap. That's what it is called as deviation method. Deviation method, where we take the assumed mean. That assumed mean is to be compared with all the given data, so that we can get the deviation. So ಎಷ್ಟು ಗ್ಯಾಪ್ ಇದೆ, ಎಷ್ಟು ಡಿವಿಯೇಷನ್ ಇದೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. ಆಮೇಲೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, we apply this formula. Okay, so just for a time being, try to get the concept of direct method, a deviation method. So when to apply this method, when to apply this method, that we will discuss when we take the problems. So for time being, just remember, in today's class we discussed about averages, meaning of averages, types of averages, 5 types of averages, arithmetic mean, okay, then median, mode, geometric mean, harmonic mean, and I told you under all these methods, all these types, we have theory as well as practical problems. So I told you one by one we take. So we started with arithmetic mean. In that, two classification, simple arithmetic mean and weighted arithmetic mean. So we discussed about simple arithmetic mean, where we have two different cases. Case number one, when given data are ungrouped. So there we use two methods, direct method. In the direct method, x bar is equal to summation x by n, and one more is deviation method, where x bar is equal to a plus summation u divided by n, where a is assumed to be. Okay. Tomorrow we take, or in our next classes we take case number 2, that is for grouped data. Okay. And what is the formula there? That also we take. Then after that we work out problems on this. So hoping that today's discussion, the concepts what we discussed today, that is clear to you. Okay. With this I conclude this particular class. So rest of the things we take in our next classes. Thank you one and all.